Go ahead and get started. So Module 7 is rational expressions. So a rational expression is, well, our definition here is a ratio of two polynomials where the denominator is not a number. So we could say constant. So basically a rational expression, I like to say, is an ugly fraction. An ugly fraction because it has a variable in the denominator. Okay, so this expression here, 1 divided by x, 1 over x, that is a rational expression. So anything with an x or a letter in the denominator is going to be a rational expression. So just here's some examples of these. So you have x plus 3 over x minus 5, x plus 7 over 2x squared plus x minus 6. And you have this one here, x to the 4th plus x to the 3rd minus 2x squared minus x over x squared minus 1. They all have an x in the denominator. One thing about these rational expressions, which we are probably going to get to at some point in here, I think when we get to multiplying and dividing, or solving them, is that they're going to have restrictions on them. Because what can you not divide by? You cannot divide by 0. Very good. So you're going to have restrictions of anything that would make a 0 in the denominator once we get to that solving piece, okay? Because we can't do that. So these are these special type of fractions. You want to look for what would make that denominator 0 when you start solving. Before we do that, though, we're going to just simplify them. So basically, we're just trying to make the fraction smaller and make it prettier. Sometimes we can, sometimes we can't. Sometimes when we simplify it, we make it uglier. Okay, but we want to follow these steps to simplify. So the first step is to factor both the numerator and the denominator as much as we can. Always look for a GCF if you can. So if I look at my numerator at x squared minus 5x minus 14, okay, I have 3 terms. Okay, so if we didn't do well on our last test with factoring, we want to maybe review some of that because it's going to be all throughout this module as well. But here, I don't have a number in front of my x squared, so I'm just going to go straight to setting this up with my 2 parentheses. I'm going to put an x in both. And then I'm going to ask myself, what are factors of 14 that might add to 5? So I'm going to start a list here. So I know 1 times 14, 2 times 7, and I think that's it. Now I'm multiplying to a negative 14. Okay, so I need 1 plus and 1 minus. And let's see, 2 and 7 do have a difference of 5. So then I just ask myself, okay, am I going to do 2 minus 7 or 7 minus 2? Which one would that be? 2 minus 7, because we have a negative 5 right here. So I'm going to go x plus 2, x minus 7. So that's my numerator. Okay, so this is going to become, on the top, x plus 2, x minus 7. Okay, then my denominator is 4x minus 8. And I want to look to factor that. Now, I don't have any x squareds, but I might be able to take a GCF out of there. Do you think I can? 4, yes. So I'm going to divide both of these by 4. When I do that, I have a 4 in front. 4x divided by 4 would give me x. And then 8 divided by 4 would give me 2. And then I have my numerator, or sorry, my denominator, 4, and then x minus 2. All right, and then step 2 is to cross out any like factors. Now, in this case, I actually don't have any like factors. Probably because I messed up when I was writing the example and probably should have put this as 4x plus 8, but that's okay. This is a case where I don't have any like factors. So I actually, all I did there was just simplify by factoring. Okay, if these were both x plus 2's, those would be like factors, and I could cross them out. But in this case, they're not, so I'm going to leave it just like this. Let's hope in another example we have some. I know we do. Yeah, the next one, yes, we should be able to. So we should be good. Okay, so let's look at example 2. We have 5a minus 35. What can I pull out of there as a GCF? 5. All right, so pull a 5 out. That's going to give me 5, and then 5a divided by 5 will give me a. 35 divided by 5 will give me 7. And that's supposed to have a 2 right there, right? Okay. All right, and then I have 6a minus 42. What can I pull out of that? 6. So divide both of these by 6. So you're going to have a 6 in front. 6a divided by 6 will be a. 42 divided by 6, 7. Okay, so now you have your fraction looks like this. 5, then a minus 7 over 6, a minus 7. Now we can do that step 2 where we cross out our like factors. So a minus 7 and a minus 7 are exactly the same. So when I divide them, I just get 1, which means I can cross them out. Okay, so it's just like doing this. You get 1, so it cancels out. Okay, so then you're left with 5 over 6, and then that would just be your answer, 5 over 6. Okay, let's look at the next example. So here we have x minus 8 over 8 minus x. So it looks like they're the same factors. They have the same numbers and letters, but they're not written the same. So what I want to do is I want to, in my denominator here, take this, the x, and I want to write it in the front. So if I move that around, this has actually got to bring the sign with it. So this is a negative x and a positive 8. Okay, so I have x minus 8 on the top. Then I have this negative x plus 8. So right now they're not actually the same. But what if I divided both of these by negative 1? So if I did that, I would have a negative 1 in the front. Negative, negative here would make that positive x. And then 8 divided by negative 1 would give me negative 8. Well, then I would have x minus 8 over negative 1, x minus 8. Now I have the same exact factor. Okay, so you might get some that look like that, and then you can cancel these out. What you're left with on the top is nothing. What do you have to put there? 1. Yeah, so 1 divided by negative 1 is negative 1. So your answer there is just negative 1. Okay, so that is actually a special case if you look down here. Okay, if you have the same sign on all of your terms, it's going to cancel out to 1. Okay, because it's just like doing 3 divided by 3 is 1. So it's the same thing here. X plus 6 divided by x plus 6 would also be 1. If it's opposite signs on all, then it crosses out to negative 1. Okay, but it has to be opposite signs on both. So like 3 divided by negative 3 would be negative 1. This one, you just have to look at both. So this x is positive, this x is negative. This 6 is positive, this 6 is negative. So they're opposite signs on both. I still like to do like what we did previously where I factor out the negative 1 just to be sure. So here I would just go like this. factor out my -1, which would give me a positive x, positive 6. Then I can cancel these out. Okay, but if you can recognize the special case, you can just say, okay, that's -1. Okay, now let's look at an example where we're simplifying, but it's actually wrong. So it looks like here, I'm taking this 3x squared plus 12x minus 15, taking a GCF of 3 out, then factoring it, and I end up with this answer here. So just take a look at that for a minute. See if you can find where the error is. Okay, so anybody want to tell me where the error is? Go ahead.
They should have done x minus 1 and then x plus 5 when they factored it.
So it looks like the factoring is incorrect here. So right here, right? In the third line? Okay, yes. So we have 3 and then x squared plus 4x plus 5, which should have been factored to x minus 1, x plus 5. Yeah, because -1 times 5 is -5. -1 plus 5 is +4 there. So we factored with the wrong signs, which then makes this, just like our first example, you've got similar factors, but nothing cancels out. So all you did there was just factor it. And you leave the answer in factored forms. I know a lot of you see the parentheses and automatically want to FOIL it. We're not doing that here. We're reducing everything as much as we can. So we want to leave everything in factored form. Okay, so now let's do with more than one rational expression. So we're going to multiply and divide these. So this is just like multiplying and dividing fractions. So multiplying, you go straight across. Divide, you keep, change, flip. Now we're just going to factor first, and then we follow those steps. So this is, looks like that didn't come through. This is 28x minus 12 over 35 times 14 over 3 minus 7x. Okay, so first thing you're going to do is you're going to factor each term, okay, as much as you possibly can. So let's see here, 28x minus 12, can I factor that? I think I can at least pull a 2 out. Anything bigger? 4, yeah, I can pull 4 out. Good. All right, so let's pull 4 out of there. That's going to give us 4 and then 7x minus 3. 35, can't do anything about that. So my first term, okay, looks like this. And then my second term, I've got 14 and then 3 minus 7x. All right, so let me just bring this down here. All right, so here's our problem. Okay, so can I do anything with this 3 minus 7x? Not yet, but what if I did what I did in the previous page, where I pulled a -1 out of there? What if I did that? So then that gave me a -1 and then a -3 plus 7x. And then I wrote that like this. -1, and then I have 7x minus 3. Because I want to be looking for like factors. Okay, so it takes a little bit of intuition with that to say, okay, maybe if I take a -1 out, that's a special case where they're opposite signs. So once you get everything simplified, then you multiply straight across, but you're not actually multiplying. Okay, here's what you're going to do. You're going to take that line, and you're just going to extend it like this. And now everything is written next to each other. Do I have anything that is the same in both the top and the bottom. 7x minus 3. Yes, they're both the same. So those are going to cancel each other out. And now I just have in the top 4 times 14, which is 56. Is it 56? 56. And 35 times negative 1, which is negative 35. And then I just say, okay, can I reduce that? I think those are both divisible by 7. Yeah. Okay, so if I do that, that gives me 8 over 5. And since you have a positive over a negative, let's take that negative, slide it right to the middle. So negative 8/5 is my answer there. All right, let's look at a harder example. This one is longer. And I'm missing a term again. Why does this copy in and over like this? So this is a 16, and that's a 12. Okay, so let's factor everything we can. So I'm going to start on the left. I have the 8b plus 24. What are both of those divisible by? Something bigger. 8, yeah. You want to get the biggest one here. So 8. So that'll give us 8. 8b divided by 8 will give us a b. 24 divided by 8 will give us 3. All right, 3a plus 12. Those are both divisible by 3. Okay, so that'll give us a 3. And then a, 12 divided by 3 will give us 4. All right, so that is my first term. So I'm just going to write it down here. All right, now let's look at my second one. I've got a squared plus or minus 8a plus 16. So let me set up my 2 parentheses, a and a. All right, factors that multiply to 16 but add to negative 8. Negative 4, negative 4, good. Negative 4 minus 4 would give me a negative 8. Negative 4 times negative 4 would give me a positive 16. All right, now my second one here, this is 4 terms. So it looks like I'm going to have to factor this by grouping. All right, so we split it down the middle. What can I pull out of AB minus 4B? They both have a B. So that would give me B, and then A, and then 4B divided by B, just a 4. And then 3A and 12, 3. So you get a plus 3. And then 3A divided by 3 would give me A, and 12 divided by 3 will give me 4. So then this factors to A minus 4, and then B plus 3. Okay, so now let's write this down here. So this is my second term. So I have times, and I'm getting, that's very crooked. So the top I had A minus 4, A minus 4. And the bottom I had A minus 4, B plus 3. Okay, so I have everything factored. Now what I'm going to do is I'm just going to take this line and extend it. And then if anything is the same on the top and the bottom, I can cross it out. So what do we got? I got 1A minus 4 on the top and one of them on the bottom. B plus 3 on the top, B plus 3 on the bottom. I have an A minus 4 and an A plus 4 there. Can't do anything with those because they're different signs. Yes. if you multiplied them, but we're not multiplying them, we're dividing them, okay? So I could try and pull a -1 out possibly, but because the a's are both positive, so not both signs are different, they're completely different, okay? So they're not going to divide. So I am left with an 8 on the top and an a minus 4, and then a 3 and an a plus 4. Okay, so 8 and 3 can't reduce, but if I could reduce that, I would want to. But there, the a plus 4, a minus 4, completely different, so we're not able to cancel those either. So this is what we're left with. So it definitely gets smaller, not as small as our last one, but it did reduce a little bit. Any other questions? All right, now dividing is same as multiplying, except you just have that keep, change, flip. So you can do that right away, or you can do it after you factor. It doesn't really matter, okay? I like to factor first. So let's take a look here. So 4x minus 12, I think we can factor that. What are these both divisible by? 4. Okay, so 4x divided by 4 would give me x, and then 12 divided by 4 would give me 3. 20x, that's just one term, can't do anything there. Same with these guys. All right, so here's what I'm looking at. 4, and then x minus 3, divided by 20x, and then divided by x minus 3 over 5x. Okay, then you do your keep, change, flip. So you keep the first fraction, change this to multiplication, flip the second fraction. So 4 times x minus 3 over 20x times 5x x minus 3. Then we do the multiply. So we extend the line and we cross out like factors. What can I cross out here? X minus 3, one on the top, one on the bottom. Anything else? Yeah, so look at this. 4 times 5 is 20, and then I have x, and then that's left with 20x. So look at that. What's 20x divided by 20x? 1. Yeah, so that's just 1. Okay, so these x's cancel. It's just 20 divided by 20. So you could have canceled the x's right here if you wanted, or you can multiply and then reduce as well. So that one's just 1. That one definitely reduces very nicely. Okay, let's take a look at another example of division. Okay, so that one copied, okay. All right, so you have x squared plus 12x plus 35. So let's set up our parentheses. Put our x's in. What's going to multiply to 35 and add to 12? 5 and 7. X plus 5, x plus 7. All right, 4x plus 28. I can divide both of those by 4, which would give me 4. And then 4x divided by 4 would give me x. 28 divided by 4, 7. X squared minus 14x plus 49. Multiplies to 49 and adds to negative 14. Good. It's negative 7, -7. So this is why we want to be good at factoring, because once you get it factored, it's pretty simple. 2x plus 10, we can divide both of those by 2. And that would give us x, 10 divided by 2, 5. So if it was negative and positive, this middle would not be there, because -7 plus 7 is 0. So they're both going to be negative, making it -14 there. Okay, so here's what we're left with. So we have our first term, x plus 5, x plus 7, over 4, and then x plus 7. And then we keep change, so I'm just going to go ahead and do that part here. So I'm going to change that to multiplication. And then I'm going to flip this. So this is a 2x plus 5 on top. And then x minus 7, x minus 7 on the bottom. So let's see what we can cancel. What can I cancel? I can do the x plus 7s because there's one on the top and one on the bottom. 2 and 4 would be 1/2, right? 1 over 2. But since these are the same, but they're both on the top, those aren't going to cancel. So I'm really left with 1 and then x plus 5, x plus 5. And then on the bottom, I've got that 2. And then x minus 7, x minus 7. Now you can write this, or I think it would be accepted like this if you wrote that in on your homework, but you're going to see it on a test or an exam like this. X plus 5 squared over 2 x minus 7 squared, just because they're copies of the same factors. Okay, let me let you guys try this next one on your own, since we just have one more example in this section. How are we doing? Okay, so let's start out with factoring top left. So it looks like I'm going to have to do grouping there. Nope, that's a 4b. Okay, so if I split this, what can I take out of here? A, good. Which will leave me with b plus 5. And what can I take out of the right? Good. So it'll leave me with plus 4 and b plus 5. So my factors are going to be a plus 4, b plus 5. All right, and then let's see. My denominator, b squared plus 14b plus 48. Let's see here. There it went. Okay, so multiplies to 48, adds to 14. 6 and 8, both positive? Both positive. Yeah. Plus 6, plus 8. All right, and then we are dividing by a squared minus 25. That's that special one where the middle term cancels out. What is that going to be? Plus and minus 5, a plus 5, a minus 5. B squared minus 64. 8, yeah, b plus 8, b minus 8. Okay, so we are going to keep, change, flip. So we're going to keep the first fraction. over here. So you have a plus 4, b plus 5, b plus 6, b plus 8, now times, and we'll flip this second fraction. Went too far. There we go. Okay, so second fraction, we'll have b plus 8, b minus 8, and then a plus 5, a minus 5 in the bottom. Okay, now let's extend this. What can I cancel? B plus 8, one on the top, one on the bottom. That's it, isn't it? That's not fun. All right, I thought we'd be able to cancel more, but we don't get to. That's okay. So we just write it out like this. A plus 4, b plus 5, b minus 8, over b plus 6, a plus 5, a minus 5. It shouldn't matter what order you put the factors in. So sometimes you can cancel them out to be nice and concise, and sometimes they end up like this, but don't multiply it out, just leave it in the factored form.